Hey, this is OXDF, and today we're going to look at another sample from Malware Bazaar. I went to Malware Bazaar today, started scrolling down until I got to the first non-exe, non-elf thing that I could play with, and it happened in this case to be a JavaScript file. As you'll see in the video that comes, we're going to take a look at the JavaScript file. We're going to find 4 or 5 different layers of JavaScript underneath there with different base64 decodings and different obfuscations to go through. We're going to see it kick off what looks like a JavaScript Vjw0rm instance, and we can actually see how it connects to the C2 and what kind of commands it gets back. And then we'll also have a jar, Java jar file that gets dropped. And we're not going to dive into the analysis of the jar itself, but we will throw it into VirusTotal. We'll see some of the history of it, how long it's been around, as well as we'll find some blog posts, including fellow content creator Jai Minton has an analysis blog post on this specific malware, so we'll definitely take a look at that. So all in all, I think it's a good time, and let's go ahead and dive in. All right, so this is our sample on Malware Bazaar. It is a JavaScript file here, scanned docu.js, and so I've downloaded a copy here, got a copy here. Let's go ahead and take a look at it in VSCode. It takes a second here. You can see right here, it's a long file, a lot of very dense stuff. Stuff at the bottom here. Anything else going on over here? And it's I'm kind of just looking at the side here to see if anything else. There's something. There was a block right there. There's a change right here. We'll want to make a note of this. And then the rest of this looks kind of like a base64 encoded string, except for, right here at the top, I'll notice right away the second character is not, hash sign, % sign are not things in the base64 alphabet, so we're going to want to check that for sure. And it's all one line. So right away, I want to change that. We're going to Control H in code here to define and replace. We'll put a semicolon here because we can see these semicolons, and we will replace them with semicolon and then Shift Enter to give myself a new line and replace all. And that worked nicely. I'm going to do the same thing with commas. Comma new line, replace all. I don't know if that's actually useful or not. No, I don't like that. Can I do it? Yeah, we're gonna leave. We're not going to do that with commas. So let's take a look. What are we doing here? It's very clear we have various different keywords here that are obfuscated away from other places they're going to be used, and they get substituted in. If I go back to the top, this variable is $512A. So the different pieces of that are getting, go further down, are getting used all in here. This all, let's go up to this. There we go. Let's see. This is all A's. I can't imagine what value that's going to have, so I'm just going to delete it. We can always come back to this. I'll call it junk. So now that makes it a little bit cleaner. Is this all one? That might be all one. So if that's the case, we're going to be in good shape here. So let's see. We can go through here and we can start to figure out what we got. So superstring is our first one, and that's going to be this base64-ish looking stuff. First one, this one right here. Could this be MKO? What's 2 would be, what's 4? 1, 2, 3, 4. Create object. Yeah, definitely create object. Looks like a. Okay, so we'll do some find and replacing here. So we'll not the right thing. Control Z, Control C, Control H, and we will put in here. We'll put. I'm not sure if I need quotes on it or not for it to be valid JavaScript. We're not trying to run it, so we're just going to replace all. And then so that was 4. Let's try. Let's say if this is 1, we can do that here as well, and replace all. That's good. I guess we can just go through and do all of these real quick. If this gets tedious, I might speed it up a little bit. As I'm doing this, I'm kind of just looking to see, does the stuff I'm putting in here make sense? And so, for example, a data type being bin base64, when we know if base64 data up here makes that feels good. So I feel like we're kind of on track here. Keep going. Here's another good example where I've got superstring replace with, replacing this hash % sign with M. So that's going to take it and make it base64 again. We can probably honestly stop here. We're going to do some stuff, create an object. Oh, look, they even have a variable junk, which is 11, which is what I've got, just junk right here, I believe. So we are correct identifying that as junk. We're going to set some stuff, but at the end of the day, we're going to run, let's see, what's 19? Probably the last one. Let's see, 11 is junk, 12, 13, 14, 15, 16, 17, 18, 19. So read text. So we're going to get the read text. We're going to read text off this com object, which we set as the text is the superstring replaced. We know the type is base64. So presumably, I mean, I don't know this for sure, but it feels like this is going to base64 decode this text and then eval it. That's probably enough for us to just move forward from here. Let's go here and we'll grab all of this. And this is where we're going to go to CyberChef. Looks like the right one. Paste that into the input. It's so big that we need some stuff. I'm going to go ahead and make a few more of these CyberChef tabs while I can, just while I'm thinking of it. Okay, so we got pasted data. We need to replace, find and replace, and that was %, I believe, with, let's make that just a simple string, with lowercase m. And then we will do base64 from base64. Let's see what we get. And cool, we've got more JavaScript, which makes sense because we passed it to eval, right? So let's grab this. We will copy that over and we'll come here and we can, here we'll make layer1.js, paste this in, and what do we have? Ooh, it's freezing up here to parse this. Look, we can see right away this is much shorter, except this this right here you can see at the bottom the bar across is going quite long. So these, it looks like it's not wrapping. Let's try view wrap, and my computer is humming up in the background as it tries to process this. I think we have two really long strings here. We can start to, just while we're waiting for the computer to catch up, like VSCode's kind of frozen right now, but we're going to keep looking at it. We're creating a WScript shell object. We're going to go into our app data directory and create a random string.js. We're going to decode this long text, and we're going to write those bytes into that JS file, and we're going to run it with the WScript.shell. So we've got a layer 2 we want to look at here. Let's see if this, oh, we crashed. Okay. We'll just reopen it. And layer 1. Looks like, okay, looks like it worked there. So we've got layer 1 long text here. It kind of you can see it changes, right? Oops, let's see. We go up. Right here, we can see it changes. So let's go here and see. We've got this one. This is what we looked at before. We were talking about. Okay, so it's going to run that, and then we got this next long text. Skip to the bottom. And there's a little bit more going on here. So this one is going to. We have the same kind of thing where we're going to replace percent or £% with, and this time, a capital A. And then we're going to get a temp, get app data. We're going to get a random string. We're going to make a text file. We're going to decode that stuff into decoded. We're going to write that into this random string.text in the actor directory. We're going to create a file system object. Now, this is interesting. So we have a few of these tries where it's trying to get the Java runtime current version, and then we're using that version to get the Java home directory. If that doesn't work, we're trying some different stuff to get the Java home directory, and then as long as it gets set, we are going to set it as that stuff /bin/. So we're finding what we think is going to be the location of the Java W executable. And then if that is not empty, so if we have it, which is reg right, it was going to do, but it doesn't do it, commented out, and then it runs that Java directory /jar, and then the stub path. So this, it looks like we have a second, the first one we ran the JavaScript file, and the second thing we ran a jar. And so if it fails to find this path to Java, down here it's going to run grab JRE from net, and it's going to actually go to filebin.net, this stuff, and get a JR, presumably what is the Java runtime environment, and download it, save it to a file, unzip it, and then it runs that newly unzipped Java runtime with the stub path. So that's pretty cool. So we have two things to investigate here. I guess we'll start with the first base64, which is called longstring1, I believe. I think we can just double click on it. Yeah, got the whole thing. Sweet. Okay, let's go up here. Knew we were going to need more CyberChefs. So we'll come here, and this we just base64 decode. I don't believe there was a any kind of substitution. And we got another superstring. That's a thing we saw before. So let's grab this. Call this like layer 2. I guess we'll call this layer 2a. Layer 2a.js. Paste that in here. It's doing the same thing it did last time, where we got these long strings that are trying to figure out how to be parsed by code, and so code is not happy with that. Interestingly, it's very similar to the original file, where we have a long string, except for a lot of this, all this stuff was obfuscated. So in our original file, I don't know if we can pull it up yet, we're frozen. In our original file, it was all this exact same stuff, except for all the strings were in different, all the strings were in like that, were in the one big variable, and then they were substituted. Funny here, this is the original, so this is the original. They were all substituted this 512a thing. Over here in layer 2, we've got a string here. We've got this stuff here, which is doing the exact same stuff we've done before, except for this time junk is just like in place. We can get rid of that. It'll make this all a lot easier to see. And we have the exact same bottom as we had before. So we can even see the stuff we didn't deobfuscate. So we're setting a type, and we're opening it, and we're writing some stuff and setting the characters to ASCII, etc. And then getting the text. So we're going to do the same thing here. This one has got we're substituting with capital A. So this would be layer 3, I guess. Let's see, do I have all that? Copy. And this time we need to do replace. We're going to find £%. That's not a regex, it's a simple string. It's a simple string. We're going to replace it with capital A. And then we're going to do base 64 from base 64. And now we have coded by Vjw0rm. Grab another one of these. We'll call this layer 3. Layer 3.js. Paste that here. We'll go ahead and take a look at it. We'll go back to that jar at the end here. So we've got some stuff up here. Bunch of different, here's Vjw0rm. So that's probably where the malware name comes from. We got some stuff going on here. So we call ns. We'll have to look at that function. Looks like we have almost like a switch statement on p sub 0 here. Where do we set p? P is equal to pt of VRE. PT. So I think we click here. Yep. So we have PT. Oh, cool. Okay. So PT is going to take VRE. I don't know what CR is yet, but we're going to then probably some here at the top. It's like some sort of web. What do we do? CR. Control F. CR. Include case here. Here we go. CR is a new ActiveX object of type N, of type J sub N. What's J? Probably the top. 1, 2, 0. Oh, Microsoft XML HTTP. Okay, so let's go back to what we just saw. We were in, I believe it was PR. Is that right? That's, oh, we'll have to just scroll down until we find it. It's right, PT. So this is going to create a new ActiveX XML HTTP object, which is like what allows JavaScript to make requests. It's going to send a post request to java.autorun.duia.ro, port 5443, with the C here. In that case, it was like, and then was the command it called with. It's going to have a random, some sort of user agent, and it's going to send it, and it's going to return the response text. And then up here, we get the response text here, and we split it on SPL. I don't know what that is. Is that available anywhere? On bar, capital V bar. And when we split it on that, now if the 0, we're going to look at the first object in that split. And so CL must be, just quits quits the current run. SC is going to create some sort of temporary file. So you can see the file name is going to be, oh, I bet you that like gets the environment variable temp slash whatever p2 was. So the server is able to send back, hey, I want you to run SC, which is this thing. P2 is the path I want you to run in temp. And then I'm going to write the P1 value into that file, and I'm going to shell.run it. So that's like running a script. Maybe that's script SC. EX, maybe it's execute, is going to just eval P1. So if my send a script back. RN, maybe run, is going to open a text file foo. It's going to read all. I don't quite know what that is. I don't know, but it's going to open another text file. Interesting, we're not using P at all. Oh, we are using P1 right here. Okay, so we're going to get VN. We're going to split it. What is VN? We can find that somewhere. Kind of file name, maybe. Or path. Not totally sure. But in conclusion, we're going to eventually run WScript. We're going to run a script on the file name here, foo, which is which is set opened up here and written to with fr, which just comes from P1. So again, we're downloading and writing something. Up, maybe it's update. It's going to get a path. It's going to create the file. It's going to do some replacing, and it's going to run again, and then it quits. So presumably when it runs the new script and quits, that's because we just updated, so we're running a new script. UN and maybe uninstall is going to do some replacing of stuff and run it. We could look at what foo is. That's set somewhere. But anyway, and then eventually it evals and quits, and then RF also write file, create file, and then it runs the file as well. So anyway, but this one is probably more like a running an executable. So and then it's going to sleep for 7 seconds and then loop again and do the same thing. So yeah, here's EX's expand variable strings. This was used in the user agent string, and so it looks like it's using that somehow to talk about tell the server certain information about maybe what's needed, or any information about the computer name, etc. Will all be kind of encoded in a normal looking Windows string. So I think we've kind of figured out. So this is the Vjw0rm part here. So that's we'll probably leave that there. Definitely from a defensive point of view, would want to look into this. I'd want to look into if I found this in my environment, I'd want to look and see has my DNS server tried to resolve java autorun.duya.ro. If I had any connections going out, maybe even connections going out on 5443. I don't know, depending on the size of your environment, that might be common. So that'd be worth checking out. Let's go back to, I think it was layer 1, where we had, so we had this first object, then we did the next thing where this is going to be our jar. So let's go down, scroll down, it's not short, unsurprisingly. And we will copy all of this, and we will note that we're going to replace with capital A. So we need another, did I nail the right number of CyberChefs? So we will do replace. In this case, we're going to do the same thing again. We're going to set this to a simple string, which will be %. And this time we're going to do capital A. And then we can do base 64 from base 64. Right away, I can see it's PK at the front, which is a zip file, magic numbers. In fact, I think we can do this. Let's see, magic. I put magic here. It'll tell us right here. That's pretty cool, actually. So it says unzip. It's offering to unzip it for us. It's showing us kind of the results of unzipping. That's kind of cool, I guess. Anyway, we have a zip file. And the fact that there's a meta inf manifest in there tells me it's like a Java or maybe like Android or Java kind of app. So we're going to save this output to a file, and we will call this, what layer are we in? Layer 2.jar. So let's see, jar. Let's see, jar. 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 Layer 2.jar. we saw it was invoked with java-jar, so it feels like a jar file, which is like a bunch of Java files put into a archive that can be run together. Let's see. Go back to a terminal here, and we can do, if we do, where did I move? Downloads layer 2.jar. There we go. We do, does it tell me it's a zip or does it tell me it's a jar? Zip, okay. If we unzip -L on that, we can see, interesting. So we have the manifest. We also have a bunch of things. There's a string carLambo, which might be useful, and there's a bunch of class files. If we unzip the maker layer 2 jar, move cd layer 2 jar, unzip dot layer 2.jar. Now I just did that so we'd be in this directory. In the meta imp part, we have manifest. So this tells us like the starting point is the carLambo.main class. Not too much else going on here that's particularly of use. One other thing we can do, we can quickly do like an MD5 sum on layer 2.jar. Let's grab this and we'll go to VirusTotal. And here we'll search for this hash. See if this has been seen before. Okay, so interestingly, this was first uploaded 2 hours ago. So someone, this is fresh, but it has been uploaded. Definitely being detected as malicious. Nothing too specific in here. Nothing like jumps out, a lot of generic Trojan-y kind of stuff. We can look on the other tabs like relations. We can see these. So it's calling out these carLambo classes, which are not necessarily new. So something is new. So we can tell right now something is new with this jar file because it is changed. But oh, interesting. Well, so it has changed, but you know, there's files uploaded from December that like the main class is the same as a file uploaded in December. The XCV class was first uploaded in early January. It does have this JavaScript file. That's the same. That OA19 is the same JavaScript, so it was uploaded here as well as Malware Bazaar. That's kind of cool. Nothing else super interesting there. So we can also look for carLambo, I believe it was, maybe malware, and we can see so STRRAT. Oh, Jai another content creator. So he has a whole analysis here of looking at the STRRAT dropper and STRRAT deobfuscation using JD GUI. I'm not going to go into this today. Not great at Java analysis, and it looks like there's a lot of good analysis already being done here that will potentially seem to apply to the same sample, or to a similar sample at least. So there's definitely stuff to look at in here. Yeah, so I think that was kind of an interesting JavaScript file. So we had JavaScript that dropped, let's see, dropped another layer that dropped another 2 layers. The first of which is a JavaScript file that got run, making another layer and another layer that we eventually got down to that Vjw0rm stuff that was, we could see the C2 where it was connecting the command and control, getting back the command and presumably the data or whatever it needed to write to a file or whatever script it was to run, etc. And then we also see it drop a jar file, which is this STRRAT, and run that as well. And kind of neat, it even went out to the internet and downloaded Java. If you don't have Java on your computer, it's nice enough to do it for you. So another malware analysis, Malware Bazaar, kind of just poking through and seeing what we find. Thanks for hanging out with me today, and we'll talk to you next time.